I hope everybody can understand me clearly. And yeah, I just want to say hello and a very warm welcome to the Zeiss webinar Quality Assurance for the Highest Medical Standards, How Measuring Data Changed the Production Process. First of all, I just want to say thank you for your interest and your participation at this webinar. And also, of course, a big thank you to Ms. Heinemann for the opportunity to get connected to you via this channel. Today I will guide you through the next 20 minutes and give you an insight in the quality assurance in medical. As Ms. Heinemann already said, there will be enough time for questions after my presentation. Just some information about my person. I'm now more than 5 years at Zeiss, and after functions in application and product management, I'm now leading our application team and the related solutions and developments in field of medical. What's the content of today's webinar? First of all, I want to present you the Zeiss group real quick. Afterwards, we are going to dive into the field of medical, and I will take a look at the regulations and standards. Of course, I will also show you a solution from Zeiss for these requirements. As an example for medical, I selected the field of orthopedics and their implants and want to highlight some application examples there for you. Conclusive, I will give you an insight in the quality assurance and the capability of optimization in production. First of all, some information about the Zeiss group. The Zeiss group is divided in 4 divisions. These are the semiconductor manufacturing technology, short SMT, the industrial quality and research, short IQR, the medical technology, and the consumer markets. The relevant division for you is the IQR, in which business I am engaged. And in this division, we are dedicated taking care of the quality assurance of several industries. For example, the field of business medical. The Zeiss Group has globally over 31,000 employees and is represented in over 15 countries with over 100 locations. Let's dive into the field of medical. Medical technology is characterized by its strong regulations, standards, and also guidelines. Every manufacturing company must, on the one hand, comply with the strict regulations, and on the other hand, have all processes validated in order to achieve the required safety in production. I would describe these validations as a hurdle that companies have to overcome. It goes without saying that these regulatory and certification requirements are justified if you remember the recent industrial scandals. These so-called hurdles naturally place high demands on the software and quality assurance. Whether it is the FDA 21, CFR Part 11, the Part 820, GAMP 5, or even the ISO 13485, the most important requirements can be, in my mind, summarized in 5 points. These are, first of all, the user management and the user roles. There have to be dedicated assignments of rights and according to users or even the user groups. For example, I have a supervisor with extended rights towards the operator. Then a second topic is the audit trail. There we need the reproducibility and the traceability of our results. And these 2 points are very, very important. On the one side, reproducibility of what has been done, who did what, when, where, and with what measuring equipment. And then if you look at traceability, especially in case of a change or a complaint. A complaint, who how, what, and a change. If you look at the results, if they have been changed, for example, in order to deliver a part, then you have to know who did this, and of course, what was it legitimate, or was there maybe a criminal intent behind? A third topic is the versioning of documents and workflows. There you need a clear structure and versioning, which document or measuring plan or test plan, inspection plan is the current and leading one. Then electronic signature, the results you have produced, for example, on the result protocol, are electronically signed, protected, and someone vouches also for them with his name. The last point here on the slide is the disaster recovery. And there, in case of a hardware breakdown, the system must be reinstalled in a short time. For these requirements to be called FDA compliant, I would like to show you an example from microscopy. And there we have our Zeiss GXP module for Zencore. In order that you can hear the audio, I just have to start the video here in GoToWebinar. Just give me a second and then it should start.
Hi, this is Chris, and today we're going to look at how you can make microscopy processes traceable and secure for all your routine tests. Everyone does routine quality assurance for their products. There are many great size analysis modules for this. You might want to look at metal grain size, the layer thickness of a coating, or pores in your ceramic. On top of that, regulation and certification are becoming more important. Think of aerospace, medical, or even just metal production. Recent scandals in automotive or the oil and steel industries have highlighted the consequences of wrong or even falsified data. Your microscope operators may need to follow long and complex operating procedures. And the results may vary depending on your user. What happens if your procedure is unclear? What happens when someone makes a mistake? What happens when someone deviates from the procedure? And what happens if someone tries to fake results, to turn a bad sample into a good one? And when you've done everything correctly, how do you prove it to your customers? If you can't trust your results, you can lose your reputation, your position, your customers. There could even be legal consequences. What if there was a way to make every process secure, to have guided workflows that produce a full audit trail? Originally developed for the highly regulated pharmaceutical industry, the GXP module makes all your analyzers traceable. A supervisor builds easy-to-follow guided workflows. All the Zeiss material modules, analytical tools, and microscope controls are available to use. Once created, the supervisor can sign off the workflows and lock them to prevent further edits. The operators run the approved guided workflows day to day. Every result is digitally signed by the user. Every change and input is seamlessly recorded, no extra effort is needed. The GXP module automatically generates an encrypted audit trail. It can be exported and shared, but not manipulated. Any deviation from procedure shows up. Any tampering shows up. It shows who did what, when, and why. Your results are searchable, safely stored, and you can always check their validity. GXP runs in our Zencore suite and is compatible with every Zencore workflow. Whatever input or output you need, GXP can make it secure and traceable. Want to find out more about Zencore capabilities? Check out more videos here.
All right, as you have seen, this solution easily overcomes the hurdles and guarantees secure processes and results. You can find more of these videos of my colleague Chris on the Zeiss homepage or on YouTube if you're interested. Let's come to orthopedics. I would like to present a few direct applications from medical technology. There, I want to take a closer look at the field of orthopedics and their implants. In a society with increasingly higher life expectancies of the population, interventions and operations on the human body are inevitably increasing. If, for example, a shoulder is worn out, an implant can be used to help. Very casually speaking, there are a number of spare parts that can be built into the body. You can see these on the graphics here on the left side. For example, implants for teeth, for shoulders, extremities, spine, hips, or the knee. Let's take a deeper look into a knee implant. An artificial knee joint consists of a multitude of components which are subject to strict quality requirements regarding dimensions and surface quality. The question now is, what are the challenges? The surface must not be touched after the final machining process. Why? This is a highly polished and mirroring surface that can get micro scratches through the tactile means contact measurement. The answer, of course, would be an optical contactless measurement of the component, but the challenge now lies in the mirroring surface and if optics is useful for it. Zeiss is here providing a solution. We have several CMMs in combination with Zeiss RDS and optical sensors, which allow to measure the part contactless. In the example knee, for example, you can also calculate a measuring time under 4 minutes. That means you have a fast measuring time. It is reproducible and reliable, and all, of course, automated in a CNC run. Regarding this, I want to show you two possible solutions. First of all, the Zeiss O-Inspect. The O-Inspect is a multi-sensor CMM, which is, for example, equipped with a dot scan white light sensor. Here you can imagine that you are touching with a light spot instead of what you usually did with a styly. For tactile measurements of the, for example, inner surface, it is also comes with a vast XXT tactile probe. For better accessibility of the workpiece, we were using a rotary table where the part is fixtured on. On the video here on the right hand side, you can see a knee implant, femoral, which is clamped on the rotary table. If I start the video here, you see the dot scan is focusing and now creating measuring points. In this case, there's a 4-axis movement used for the measurement, means the axis of the rotary table rotates the part and the 3 axes of the CMM move the sensor to keep the distance between the sensor and the workpiece itself constant. And also to realize the angle of incidence of the light to be perpendicular to the surface. So to speak, to follow the workpiece or the sample. Another alternative would be the Portal CMM Zeiss Prismo, which is likewise equipped with a dot scan and a rotary table. Here you can directly see the difference to the previous presented solution at the O-Inspect. There, the rotary table was horizontally installed, and here it is vertically aligned. The rotation of the dot scan here is realized via RDS, and which is a carrier with a turn and a swivel axis. The mirroring surface on the component can be seen very clearly here in the video. And now you again see the distance between sensor and workpiece. A surface is kept constant by means of the 4-axis movement. Here you can see now how the profile on the surface is scanned. Correct. If you are interested in further application examples, you will find them on the Zeiss homepage or, of course, also on site in Oberkochen in our customer center. Let's come to the production. Especially in the medical sector, an enormous percentage of the producted parts must be inspected, or in some cases, even a 100% inspection must be carried out. With this high throughput, you naturally very quickly come to the approach of optimization in order to, of course, save time and thus money. But what does efficient testing and documentation look like in today's measuring or measurement technology? Therefore, let's take a direct look at the production and the quality assurance system which is used there. First of all, I have my hardware, a measuring device, no matter whether it is a CMM or a CT, a scan box or microscope, or even several variable used machines in one lab. This device is often loaded automatically for high quantities. And in this example, there's a shuttle system shown which is used to load the CMM with the parts to be measured. Zeiss offers their one-stop solution containing styli, fixtures, and for example, also tools for temperature monitoring. Of course, auto programming or project processing is also possible there. The entire quality process is then operated and monitored via software packages. For example, Calypso for operating CMMs, Sencor for microscopes, or FACS as an automation interface. For data visualization and analysis, I can then connect all these measuring equipments to PyWeb. An enormous importance for manufacturing companies in the medical sector is the inspection planning. This means a superordinate system that manages test procedures and addresses the test orders to the corresponding measuring device. This leads me to Zeiss Gardus MES system. Let me give you a small example of optimization which is then possible in production. Gardus takes over the entire inspection planning and manages all test orders. The measurement equipment itself, in this example a CMM that is operated with Calypso, executes the specifications of Gardus. This means that an inspection order is sent to the CMM, executed there, and the data or results are transferred again. Of course, all of the shown requirements from the first slides are fulfilled here. As an optimization, I can now, of course, optimize the inspection itself. This can be done either by time, by the number of components to be inspected, or by the number of inspection relevant characteristics. Let's start by time. Instead of one test every 4 hours after the test of the last samples were positive, the time is now be set, for example, to 8 hours. This means that the comment to Calypso only comes every 8 hours. Then by components, it is no longer necessary to check all cavities during injection molding, for example. And then very interesting, by inspection relevant characteristics. It is no longer necessary to measure all inspection characteristics. Let me give you an example there. For example, we say we have 25 characteristics, means diameters, flatness, and so on, and they all have to be inspected on one part. Now, however, 16 of the features are so stable that no changes in the production process are to be expected. Then the specification from Gardus to Calypso can include that now only 9 characteristics need to be checked instead of the 25, as these are not stable or extremely critical. If a characteristic is then out of tolerance, it is of course immediately reset to full scope of the inspection. All these mentioned points hold, of course, then enormous potential for the factors time and cost in your production. Yes, I hope I could give you a brief insight into the world of quality assurance by Zeiss in that short 20 minutes. And yeah, looking at my watch, there would be still enough time for your questions now.
Yes, thank you, Mr. Zimmermann, for your presentation. If there are any questions, you can also post them now and write them. So don't hesitate to ask questions.
Let's just wait, maybe what is coming in here. All right, I see the first question. It is, do reflective surface bother the dot scan? Good question. For this, I have to explain the use technology a little bit. The dot scan is a white light sensor using the chromatic confocal principle. The advantage of this principle is that mirroring surfaces, as for example the knee, are no problem to measure. This means that you do not have to spray the component with a matting spray before the measurement, as it is the case with a triangulation sensor. This would naturally, of course, change then the surface and then the dimensions of the part. With the dot scan, it is so possible to do that, and it's even possible to go so far that you can measure the thickness of layers depending on the material. Hope that answered your question here. Okay, another question is popping up. Is the GXP module in Sencor already used at the customer side, or is it a beta development? The module is already being used in the market, and no beta development anymore, and very successfully applied by numerous customers. Let's just wait. If there's something else popping up, I'll give you a minute.
Okay, if there are no more questions so far, you can both contact Mr. Zimmermann via the address shown on the slide right now, and you can also find the contact data in the webinar planner. In
Correct.
the webinar planner, you can also download your participation certificate for this session. And that leaves me to say thank you, Mr. Zimmermann, for your presentation. And thanks to all attendees for your interest in the presentation and in the METAV web sessions. The METAV web sessions will continue until tomorrow. So if you are interested in other talks, don't miss that opportunity. And the METAV fair will take place next year from 23rd to 26th of March. I'm looking forward to seeing all of you there.
Right. I would also like to thank you very much for your attention. And yeah, as mentioned, if there's anything unclear, please feel free to contact me at the email address, which is shown on the slide here. And yeah, thank you very much, and hopefully see you at the next webinar. Take care and goodbye.